given y varies directly as x. So, and they also say that when x equals 10, y equals 50, so find the constant of variation and the equation of variation. So we start off with what it said here, y varies directly as x. So y equals a constant times x. So we use the given information to find the constant, the k. When x equals 10, y equals 50. So when x is 10, right here, y is 50, we solve for k. Divide 10 on both sides, and we get k equals 5. That's what you can also write, k equals 5. And so when we rewrite the equation of variation, we plug in the 5 right there, and that's the equation. Y equals 5 times x. Now we can determine y whenever we know x. Now here's talking about proportionality. Proportionality. Things being proportion. So y is directly proportional to x. When x is 10, y is 30. What is y when x equals 25? Sounds like the previous problem, and it is actually. Directly proportional means that when you put them in a proportion, y to x, it equals a constant. Well, if that's true, then all we have to do is multiply both sides by x, and you would get this, y equals kx. And that's the same exact thing as direct variation. So they mean the same. Directly proportional and varies directly mean exactly the same thing. So this we'll have to go through these steps in order to answer this original question. So we're going to find the constant of proportionality, which is the same as the constant of variation. So it said when x is 10, y is 30. So taking the equation, when y is 30 and x is 10, we find the k. Divide by 10 on both sides, k equals 3. Now we know the proportionality constant, which is the same as the constant of variation. So then we put in the 3 into our equation, our y equals kx, so it's y equals 3x. Now we can find any y given any x and vice versa. So it said what was y when x is 25. So x is 25, put that in there, and figure out that y is 75. Okay, here's an application example. The distance an object falls when it is dropped is directly proportional to the square of the amount of time since it was dropped. This is a physics problem, actually. And then they gave us an object falls 44.1 meters in 3 seconds. Find the distance the object falls in 10 seconds. So we used this directly proportional concept, and it's proportional to the square of the time. So d, proportional to the square of the time, distance is proportional to the square of the time, means that d over t squared is a constant. But that means the same thing as direct variation. So you can just actually start off with this. You don't even need this. You can start with this right here. And then you say, use this information. When you have 3 seconds over here, you come out with 44.1 meters. So that's 9 times k equals 44.1. So solve for k. Divide both sides by 9. K equals 44.1 over 9, which is 4.9. Now, come over here, use the equation. D equals, now you know that K is 4.9, so you plug it in right there. And then you answer the question. find the distance the object falls in 10 seconds. So you put the 10 in there, you square it out, 100 times by 4.9, you get 490 meters. That's the answer to the question. Now, you might be wondering about the units of K. It's like, is it meters, is it seconds, what is it? Well, it turns out it's meters per second squared, which are the units of what's called acceleration. In this case, it's the acceleration due to gravity. Of course, in our equation, we've divided by 2. Anyway, don't worry about that. The units of this are meters per second squared, and the way you know that is distance is meters, 4.9 is in meters per second squared, and time is in seconds, and being squared, that's seconds squared. So the second squareds cancel out, and meters equals meters. That's how you know that these are the right units of the K.